What if the key to humanity's survival isn't on Earth, but floating millions of miles away in the vast emptiness of space? Right now, scientists and engineers are racing against time to develop technologies that could make life in space not just possible, but sustainable and even comfortable. From self-sustaining habitats to revolutionary propulsion systems, the inventions of tomorrow are being designed today to ensure we can thrive beyond our planet. In this video, we'll uncover 50 futuristic innovations that could completely transform how we live, work, and explore the cosmos. These aren't just ideas from science fiction, they're real breakthroughs that could shape the future of humanity. So, are you ready to take a journey into the unknown and discover the technologies that might one day carry us to the stars? Picture a home that doesn't just exist in space, but thrives there, producing its own oxygen, recycling water, and even growing fresh food. This is the vision behind self-sustaining space habitats, a groundbreaking invention that could redefine how we live beyond Earth. These habitats rely on advanced closed-loop systems where every resource is reused in a continuous cycle, mimicking the delicate balance of ecosystems on our planet. Bioregenerative life support systems are at the heart of this innovation, using plants, algae, and microbes to generate oxygen, purify water, and provide sustenance. NASA has already been testing these systems with projects like the Bioregenerative Life Support Systems showing incredible promise for long-term missions. Imagine a future where astronauts on Mars live in habitats where the air they breathe and the food they eat are produced right there, minimizing the need for costly and risky resupply missions from Earth. But to make this vision a reality, we'll need more than just life support. We'll need technologies that ensure these habitats are not only functional but truly sustainable. One of the biggest hurdles to long-term life in space isn't just the lack of resources, it's the absence of gravity. In microgravity, the human body undergoes dramatic changes. Muscles atrophy, bones weaken, and even the cardiovascular system struggles to function normally. These effects pose a serious risk to astronauts on extended missions, making artificial gravity systems a game changer for space exploration. One of the most promising solutions involves rotating space stations or centrifuges, which use centrifugal force to simulate gravity. Picture a massive spinning habitat where the outer walls become the floor, allowing inhabitants to walk, run, and live as they would on Earth. Concepts like NAS and Nautilus X have already explored this idea, proposing a modular spacecraft with a rotating section to create artificial gravity. While these designs are still in the experimental phase, they represent a crucial step toward ensuring the health and well-being of future space travelers. After all, if we're going to call the stars our home, we'll need to feel at home in every sense, physically, mentally, and emotionally. While we've made incredible strides in renewable energy here on Earth, space offers a unique opportunity to take solar power to the next level, literally. Enter space-based solar power, a concept that involves capturing the sun's energy directly in orbit and beaming it back to Earth or other space habitats. Why go to such lengths? For starters, solar panels in space aren't limited by weather, clouds, or the day-night cycle, meaning they can generate energy 24/7. The sun's rays are also far more intense in the vacuum of space, allowing for significantly higher energy yields. Countries like Japan are already leading the charge with initiatives like the Space Solar Power Systems project, which aims to build a massive solar array in orbit by the 2030s. But the real magic lies in the technology that transmits this energy: microwaves or lasers that can safely and efficiently send power across vast distances. Imagine a future where entire cities are powered by solar arrays floating in space, freeing us from the constraints of fossil fuels and land-based renewables. This isn't just about energy for Earth, It's a critical step in enabling long-term missions to the Moon, Mars, and beyond. After all, if we're going to make space our new frontier, we'll need a reliable and abundant source of power to fuel our ambitions. Living in space comes with a hidden hazard that's far more insidious than the absence of gravity cosmic radiation. Beyond Earth's protective atmosphere and magnetic field, astronauts are bombarded by high-energy particles from the sun and deep space, posing serious risks to their health. Over time, this exposure can lead to cancer, neurological damage, and even DNA mutations, making it one of the greatest challenges for long-term space travel. That's where advanced radiation shielding comes in. Scientists are turning to innovative materials like hydrogen-rich polymers, which are incredibly effective at blocking harmful particles due to hydrogen's low atomic weight. Think of it as a cosmic force field that absorbs and deflects radiation before it can reach the crew. Another promising approach involves creating artificial magnetic fields, similar to Earth's magnetosphere, to divert radiation away from spacecraft. Projects like the European Space Agency's SuChield and NASA, a research into superconducting magnets, are paving the way for these futuristic solutions. The stakes couldn't be higher. Without proper shielding, deep space missions to Mars and beyond could become impossible. As we venture further into the cosmos, protecting astronauts from this invisible threat isn't just about safety, it's about ensuring the very survival of our species in the stars. Imagine being millions of miles from Earth, only to realize you're missing a crucial tool or part needed to complete a mission. In the past, this could spell disaster, but thanks to 3D printing, it's now a solvable problem. 3D printing in space is a revolutionary technology that allows astronauts to manufacture tools, spare parts, and even entire structures on demand, right where they're needed. Take NASA Refabricator, for example. This compact device, currently aboard the International Space Station, not only prints objects but also recycles plastic waste into new materials, creating a closed-loop system that's both efficient and sustainable. This means that instead of waiting months for resupply missions, astronauts can produce everything from wrenches to medical instruments in a matter of hours. But the potential doesn't stop there. Researchers are exploring the possibility of using 3D printers to construct habitats on the Moon or Mars, using local materials like lunar regolith or Martian soil. This could drastically reduce the costs and risks associated with transporting heavy equipment from Earth. By enabling on-site manufacturing, 3D printing is paving the way for true self-sufficiency in space, ensuring that future explorers have the resources they need to survive and thrive in the harshest environments imaginable. Rocket launches are thrilling, but they're also incredibly expensive, inefficient, and harmful to the environment. What if there was a way to reach orbit without burning thousands of tons of fuel? Enter space elevators, a concept that sounds like science fiction but is rooted in solid science. The idea is simple yet groundbreaking. A cable anchored to the Earth's surface extends tens of thousands of miles into space, connected to a counterweight in geostationary orbit. Climbers, essentially elevator cars powered by electricity, would travel along this cable, transporting people and cargo to orbit at a fraction of the cost of traditional rockets. The key to making this possible lies in carbon nanotubes, a material stronger than steel but incredibly lightweight, capable of withstanding the immense tension of such a structure. Companies like Obayashi Corporation in Japan are already working on plans to build a space elevator by mid-century, with the goal of reducing the cost of space travel to just a few dollars per kilogram. But the challenges are immense, from engineering the cable's durability to protecting it from space debris and weather. Despite these hurdles, the potential rewards are staggering. Imagine a world where accessing space is as routine as taking a train. As we look to the future, space elevators could revolutionize not just how we reach orbit, but how we think about exploration and commerce in space, the next step. Developing the technology and infrastructure to make this vision a reality, paving the way for a new era of space travel. While we often think of space as a vast, empty void, it's actually filled with untapped treasures: asteroids. These rocky bodies, remnants of the solar system's formation, are packed with valuable resources like platinum, gold, and even water. Asteroids could hold the key to solving some of humanity's greatest challenges, from resource scarcity on Earth to sustaining life in space. Imagine extracting water from an asteroid not just for drinking but for splitting into hydrogen and oxygen, creating breathable air and rocket fuel. This process, known as in situ resource utilization, could revolutionize space travel by reducing the need to haul supplies from Earth. Companies like Planetary Resources are at the forefront of this endeavor, developing technologies to identify and mine these celestial gold mines. Their vision isn't just about economic gain, it's about enabling long-term exploration and colonization of space. By harnessing the resources already floating in our solar system, we can build a sustainable future beyond our planet. And the benefits aren't just limited to space. Asteroid mining could also bring rare metals to Earth, driving innovation in industries like electronics and renewable energy. As we look to the stars, it's clear that the real treasure isn't just out there. It's the potential to transform how we live, work, and explore in the cosmos. Now, let's dive into a technology that could redefine the way we communicate across the cosmos: quantum communication networks. Unlike traditional methods that rely on radio waves, which can be slow and vulnerable to interception, quantum communication leverages the bizarre phenomenon of quantum entanglement. This principle allows particles to become so deeply linked that the state of one instantly influences the state of another, no matter how far apart they are. Imagine sending a message from Earth to Mars and having it arrive instantaneously, with zero risk of eavesdropping or interference. China has already made strides in this field with their MISHA satellite, which successfully demonstrated quantum key distribution over a distance of 1,200 kilometers. This breakthrough paves the way for ultra-secure communication networks that could connect future colonies on the Moon, Mars, and beyond. But the implications go even further. Quantum communication could also enhance the precision of deep space navigation, ensuring spacecraft stay on course during long journeys. As we venture deeper into the solar system, maintaining reliable and secure communication will be essential for coordinating missions, sharing discoveries, and keeping explorers connected to home. This isn't just about sending messages faster, it's about building a communication infrastructure that can support humanity's expansion into the stars. Feeding a crew on a long-term space mission isn't just about packing enough meals. It's about creating a system that can sustain life far from Earth. Enter space-based agriculture, a field that's revolutionizing how we grow food beyond our planet. Traditional farming methods don't work in microgravity, but innovative techniques like hydroponics and aeroponics are stepping up to the challenge. Hydroponics, which grows plants in nutrient-rich water instead of soil, and aeroponics, which mists roots with a nutrient solution, are both ideal for space environments where resources are limited and every gram counts. NASA Veggie Project, a small plant growth system aboard the International Space Station, has successfully grown lettuce, radishes, and even zinnias, proving that fresh produce can thrive in zero gravity. But it's not just about feeding astronauts. Studies show that tending to plants can have psychological benefits, reducing stress and improving morale during long missions. Of course, challenges remain, from ensuring plants get enough light to managing water and nutrients in a closed-loop system. Yet, as we push further into space, the ability to grow food on demand could be the difference between survival and thriving. It's more than a scientific breakthrough, it's a step toward making space feel a little more like home. Think about the last time you used a self-driving car. Now imagine that same technology, but scaled up to navigate the infinite void of space. Autonomous spacecraft are no longer a futuristic dream. They're a reality transforming how we explore the cosmos. By integrating artificial intelligence and machine learning, these spacecraft can operate independently, making split-second decisions without human intervention. This autonomy is crucial for missions where communication delays are inevitable, like a rover on Mars, where signals from Earth can take up to 20 minutes to arrive. NASA Curiosity and Perseverance rovers are prime examples, equipped with AI that allows them to analyze terrain, avoid obstacles, and even select their own scientific targets. The benefits go beyond just convenience. Autonomy reduces the risk of human error and enables missions to tackle more complex challenges, like navigating treacherous lunar craters or charting the icy moons of Jupiter. But this isn't just about rovers. Future spacecraft could use AI to repair themselves, manage resources, and even collaborate with other autonomous systems to build habitats or mine asteroids. As AI continues to evolve, it's becoming clear that the future of space exploration will rely on machines that can think, adapt, and act on their own. This shift isn't just about efficiency, it's about expanding the boundaries of what's possible in the cosmos, one intelligent spacecraft at a time. The idea of vacationing in space might sound like a fantasy, but it's rapidly becoming a tangible reality thanks to the rise of space tourism infrastructure. Companies like SpaceX and Blue Origin are leading the charge, with ambitious plans to make space travel accessible to more than just astronauts. One of the most exciting developments is the concept of orbital hotels, luxurious accommodations floating hundreds of miles above Earth, offering breathtaking views of our planet and the cosmos. Projects like the Aurora Station, planned by Orion Span, aim to host guests in orbit by the 2030s, complete with all the amenities of a high-end resort. But to make these dreams a reality, we'll need more than just hotels. We'll need commercial spaceport hubs designed specifically for the safe launch and return of civilian spacecraft. Facilities like Spaceport America in New Mexico are already paving the way, creating a foundation for a booming space tourism industry. The economic potential is staggering, with some estimates suggesting the global space tourism market could reach billions of dollars within the next decade. Beyond the financial benefits, this infrastructure has the power to democratize space, making it a destination for explorers, adventurers, and even everyday travelers. As public interest in space travel continues to grow, fueled by high-profile missions and media coverage, the dream of booking a ticket to orbit is closer than ever. This isn't just about luxury, it's about inspiring a new generation to look to the stars and see them not as distant, unreachable points of light, but as places we can visit, explore, and call our own. Staying connected on Earth is one thing, but what about maintaining a seamless internet network across multiple planets? Enter Interplanetary Internet, a concept that could transform how we communicate across the vast distances of space. Unlike our current internet, which relies on continuous connections and minimal delays, interplanetary networks face challenges like signal lag and interruptions caused by planetary orbits, solar flares, and the sheer scale of space. To tackle these hurdles, scientists are developing delay-tolerant networking, or DTN, a system designed to store and forward data in chunks, ensuring messages eventually reach their destination even if there's no immediate connection. Think of it like an interstellar postal service where data packets wait patiently for the next available opportunity to move forward. NASA has already tested DTN on missions like the Deep Impact spacecraft, demonstrating its potential to keep future colonies on Mars and beyond in touch with Earth. But why is this so crucial? Beyond enabling video calls and social media in space, reliable communication is the backbone of scientific collaboration, mission coordination, and even emergency response. It's about more than just convenience. It's about creating a network that unites humanity across the solar system, fostering discovery and connection no matter how far we roam. Medical research has always been tied to Earth's gravity, but what if the key to groundbreaking discoveries lies in leaving it behind? Space-based medical labs are opening a new frontier for science, leveraging the unique conditions of microgravity to unlock insights that are impossible to achieve on the ground. In low gravity, cells and tissues behave differently, allowing researchers to study diseases, test new drugs, and even grow human organs in ways that were previously unimaginable. One of the most promising areas is tissue engineering on the International Space Station. Scientists have successfully grown beating heart cells and complex tissue structures, offering hope for future organ transplants and regenerative medicine. Space also provides an ideal environment for drug development, where molecules crystallize with unparalleled precision, leading to more effective treatments for conditions like cancer and Parkinson's disease. Experiments like the Lambda Vision project, which is developing artificial retinas in space, highlight the potential of these labs to revolutionize healthcare. But the benefits aren't confined to space. What we learn in orbit could lead to breakthroughs that save lives on Earth, from faster vaccine development to innovative therapies for chronic illnesses. This intersection of space exploration and healthcare isn't just about advancing science. It's about improving the quality of life for people everywhere. As we continue to push the boundaries of medical research, space-based labs are proving that the next giant leap for humanity could be in healing, not just exploration. While traditional rocket engines have brought us to the moon and beyond, they're not the most efficient option for the vast distances of deep space. That's where plasma propulsion systems come in, a cutting-edge technology that could revolutionize how we travel through the cosmos. Unlike chemical rockets, which burn fuel to produce thrust, plasma thrusters use electric fields to accelerate charged particles or plasma to incredibly high speeds. This method is far more efficient, allowing spacecraft to travel farther with less fuel, making it ideal for missions to distant planets like Mars or even Jupiter's moons. One of the most well-known examples is NASA's Next Ion thruster, which has been tested for thousands of hours and could one day power crewed missions across the solar system. But plasma propulsion isn't just about efficiency, it's about expanding the possibilities of exploration. With these systems, spacecraft could reach destinations that were once considered too far or too costly to attempt, opening up new frontiers for discovery. Research is already underway to improve thruster designs, increase power output, and tackle challenges like wear and tear on engine components. These advancements aren't just theoretical, they're paving the way for a future where humanity can venture deeper into space than ever before. As we look to the stars, it's clear that propulsion technology will play a pivotal role in turning our boldest dreams of exploration into reality. You might not see it from Earth, but our planet is surrounded by a floating junkyard of defunct satellites, spent rocket stages, and fragments from past missions. This space debris, traveling at speeds of up to 28,000 kilometers per hour, poses a serious threat to current and future space operations. Even a tiny piece of debris can cause catastrophic damage to spacecraft, satellites, or even the International Space Station. As the number of objects in orbit continues to grow, the need for effective cleanup solutions has never been more urgent. Enter space debris cleanup technologies, a new wave of innovations designed to tackle this cosmic clutter. One approach involves robotic arms equipped with grippers to capture and deorbit large debris, like the European Space Agency's Clear Space mission, which aims to remove a defunct satellite by 2025. Another strategy uses nets or tethers to ensnare smaller fragments, while experimental laser systems are being developed to zap debris out of orbit by nudging it into the Earth's atmosphere where it burns up harmlessly. These technologies aren't just about cleaning up the mess we've already made. They're about creating a sustainable environment for the future of space exploration. With thousands of new satellites planned for launch in the coming years from companies like SpaceX and OneWeb, the stakes are higher than ever. If we don't act now, the growing cloud of debris could make key orbits unusable, jeopardizing everything from global communications to scientific research. This isn't just a technical challenge, it's a call to protect the shared frontier of space, ensuring it remains accessible and safe for generations to come. Imagine embarking on a journey to a distant star system, only to wake up decades later without having aged a day. This isn't the plot of a sci-fi movie, it's the promise of cryogenic sleep chambers, a groundbreaking invention that could transform the future of long-duration space travel. Cryogenic sleep, or cryosleep, involves placing humans in a state of suspended animation by drastically lowering their body temperature, slowing metabolic processes to a near halt. This not only reduces the need for food, water, and oxygen during long missions, but also minimizes the physical and psychological toll of extended space travel. Research in this field is already underway, with organizations like the SpaceWorks enterprises developing technologies to safely induce and reverse this state. The potential applications are staggering. Missions to Mars, interstellar exploration, or even long-term settlements on distant worlds could all benefit from cryosleep. But it's not without challenges. Scientists must overcome issues like preventing cell damage during freezing and thawing, as well as ensuring the long-term safety of the process. Beyond the technical hurdles, cryogenics raises profound ethical questions. Who decides who gets to hibernate and for how long? What happens if something goes wrong millions of miles from Earth? Despite these uncertainties, cryosleep could be the key to unlocking humanity's ability to explore the farthest reaches of the cosmos. By making long journeys feasible and sustainable, this technology opens the door to adventures that were once the realm of dreams. It's not just about surviving the journey, it's about redefining what's possible in the age of space exploration. Looking up at the night sky, we've always wondered what lies beyond the stars. But it's space-based telescopes that are truly unlocking the secrets of the universe, offering views of distant galaxies and exoplanets that were once beyond our reach. Unlike Earth-bound telescopes, which are hindered by atmospheric distortion, space telescopes operate in the pristine clarity of orbit, capturing images with unprecedented detail. The James Webb Space Telescope, launched in 2021, is a prime example of this leap forward. With its massive gold-coated mirror and advanced infrared sensors, Webb can peer through cosmic dust clouds to study the formation of stars and planets, and even analyze the atmospheres of distant worlds for signs of habitability. Other projects like the Nancy Grace Roman Space Telescope, set to launch in the late 2020s, aim to build on this legacy by mapping dark matter and discovering thousands of new exoplanets. But why does this matter? These telescopes aren't just about stunning images, they're about answering fundamental questions. Are we alone in the universe? How did galaxies form and evolve? What lies beyond the edges of our cosmic horizon? By placing these observatories in space, free from the distortions of Earth's atmosphere and the interference of light pollution, we're gaining a clearer picture of the cosmos than ever before. The discoveries made by these instruments could reshape our understanding of physics, astronomy, and our place in the universe. This isn't just about observing the stars, it's about unlocking the mysteries of existence itself, one groundbreaking image at a time. Picture this, a factory floating in orbit producing materials so unique they can't be made on Earth. This isn't a futuristic fantasy, it's the cutting-edge reality of space-based manufacturing. In the microgravity environment of space, physical processes behave differently, allowing for the creation of products with extraordinary precision and purity. Take ultra-pure crystals, for example. On Earth, gravity causes imperfections as materials solidify, but in space, crystals form flawlessly, making them ideal for advanced electronics and medical imaging. Similarly, fiber optics, essential for high-speed internet and telecommunications, can be manufactured in space with unparalleled clarity, boosting their efficiency and performance. The International Space Station has already hosted experiments in this field, with companies like Made in Space pioneering the 3D printing of tools and components in orbit. Beyond the technological breakthroughs, the economic potential is staggering. Space-based manufacturing could give rise to entirely new industries, from pharmaceuticals to advanced materials, while driving innovation here on Earth. The benefits aren't just theoretical, they're already being realized, with products made in space returning to revolutionize industries. As commercial space ventures gain momentum, this sector is poised to become a cornerstone of the next industrial revolution. The question isn't just what we can make in space, it's how these innovations will reshape our world, turning the stars into a launch pad for progress. Satellites have long been our eyes in the sky, helping us predict storms, track hurricanes, and monitor climate trends. But what if we could go beyond just observing the weather and actually influence it? This is the ambitious vision behind space-based weather control, a concept that blends cutting-edge technology with the urgent need to address climate change. Satellites like NOAA GOES-Ceres and Europe's Meteos are already essential tools for weather forecasting, providing real-time data that saves lives during natural disasters. But the next frontier involves using these platforms to intervene, whether by seeding clouds to induce rainfall, deflecting solar radiation to cool the planet, or even preventing the formation of destructive storms. One proposed method involves deploying a network of solar reflectors in space to reduce the amount of sunlight reaching Earth, potentially offsetting the effects of global warming. While these ideas are still in the experimental phase, the potential to mitigate extreme weather events and slow climate change is enormous. This intersection of space technology and environmental sustainability isn't just about solving problems, it's about reimagining our relationship with the planet we call home. By harnessing the power of space, we could create a future where humanity not only adapts to climate challenges, but actively shapes the environment for the better. The stars may hold the key to protecting Earth itself. Powering life in space requires more than just generating energy, it's about storing it efficiently for when it's needed most. This is where space-based energy storage comes into play, a critical innovation that could support everything from long-term missions to future colonies on distant planets. Imagine orbital batteries or supercapacitors floating in space, capable of storing vast amounts of energy harvested from solar arrays. These systems would ensure a steady power supply during the long nights on the Moon or Mars, or during periods when spacecraft are out of direct sunlight. On Earth, the same technology could revolutionize renewable energy grids, storing excess solar or wind power in orbit and beaming it back when demand peaks. One of the biggest challenges, however, is creating storage devices that can withstand the harsh conditions of space: extreme temperatures, radiation, and microgravity, without losing efficiency or reliability. Researchers are already exploring solutions, such as advanced materials and modular designs that can be assembled in orbit. Prototypes like NASA, a robotic refueling mission, are testing ways to maintain and upgrade energy systems in space, paving the way for more sustainable storage solutions. This isn't just about keeping the lights on, it's about ensuring the success of missions that will take humanity deeper into the cosmos. Effective energy management is the backbone of space exploration, enabling us to push beyond the limits of today and power the dreams of tomorrow. As we venture deeper into space, one question looms large. How do we handle the dangerous and demanding tasks required to build and maintain habitats, repair spacecraft, or explore uncharted terrains? Enter space-based robotics, a game-changing innovation designed to shoulder the risks and challenges that would be too perilous for humans. Robots like NAS, a Robonaut, a humanoid machine equipped with dexterous hands and advanced sensors, are already proving their worth aboard the International Space Station. These robots can perform intricate repairs, assist astronauts with daily tasks, and even handle tools designed for human hands, but their potential goes far beyond assisting crews. Imagine autonomous robots constructing bases on the Moon, assembling large-scale solar arrays in orbit, or scouting the treacherous surfaces of Mars to prepare for human arrival. By taking on these high-risk activities, robotics not only minimizes danger to astronauts but also accelerates the pace of space exploration. Projects like the European Space Agency's EROS, which focuses on servicing satellites in orbit, and Japan's Kibo robot, which supports experiments in the ISS, are paving the way for a future where machines and humans work side by side in space. This isn't just about replacing human effort, it's about amplifying it, allowing us to tackle monumental projects that would otherwise be impossible. Automation is quickly becoming the backbone of space infrastructure, ensuring we can build, explore, and thrive beyond Earth's boundaries. As we look to the stars, it's clear that the robots of tomorrow will be our partners in unlocking the cosmos. Water is the lifeblood of any habitat, and in the harsh environment of space, every drop counts. That's where space-based water recycling systems come into play, turning what could be a critical challenge into a sustainable solution. Advanced technologies like NAS, a water recovery system, currently in use aboard the International Space Station, are at the forefront of this innovation. This system collects wastewater from various sources: urine, sweat, even moisture from breathing, and purifies it into clean, drinkable water. In fact, the system recovers about 93% of the water on the ISS, a remarkable efficiency that ensures long-term missions can operate without constant resupply from Earth. But the implications go far beyond just survival. Future missions to the Moon, Mars, and beyond will rely on these systems to create closed-loop ecosystems where every resource is reused in a continuous cycle. Imagine a lunar base where water isn't just consumed but regenerated, supporting life for years or even decades. Companies like Ecolab are already working on next-generation recycling technologies, aiming to make these systems even more efficient and compact for deep space travel. The importance of water conservation in space can't be overstated. It's not just about quenching thirst, but also about growing food, generating oxygen, and even producing rocket fuel. This isn't just a technological breakthrough, it's a fundamental shift in how we approach resource management in space. As we strive to make extraterrestrial habitats a reality, these recycling systems are proving that sustainability isn't just a goal, it's a necessity for thriving beyond Earth's limits. Think about the waste we generate here on Earth. Now imagine trying to manage it in the confined, zero-gravity environment of a spacecraft. Space-based waste management is a critical challenge that demands innovative solutions, and scientists are rising to the occasion with groundbreaking technologies. One of the most promising approaches is waste-to-resource conversion, where trash is transformed into something valuable like fuel, water, or even building materials. On the International Space Station, experiments like the trash compaction and processing system are turning waste into compact bricks, reducing volume and making storage more efficient. But the innovation doesn't stop there. Researchers are exploring ways to use microbes to break down organic waste into nutrients for growing plants. or even converting it into energy through advanced biodigestion processes. The challenges are significant. In microgravity, waste doesn't behave the same way it does on Earth, making containment and processing far more complex. Companies like Tether's Unlimited are developing systems like the Positrash Recycler, which uses heat and pressure to break down waste into reusable materials. These solutions aren't just about keeping spacecraft clean. They're about creating a sustainable ecosystem where nothing goes to waste. As we look to establish long-term habitats on the Moon or Mars, efficient waste management will be essential for maintaining health, conserving resources, and ensuring missions can operate independently of Earth. This isn't just a technical problem, it's a cornerstone of our ability to thrive in the cosmos, proving that even in space, sustainability starts with how we handle what we leave behind. Even in the vastness of space, the human mind craves connection to nature, to home, and to the familiar. That's where space-based virtual reality steps in, offering a lifeline to Earth-like environments for astronauts isolated millions of miles away. VR technology isn't just about games or entertainment. It's a powerful tool for mental well-being, helping astronauts combat the psychological strain of long-term missions. Imagine putting on a headset and suddenly finding yourself walking through a lush forest, lounging on a beach, or even visiting your favorite city. These immersive experiences can alleviate feelings of isolation and homesickness, which are some of the biggest challenges faced by crews on extended missions. NASA has already begun exploring this concept with projects like the Virtual Reality Laboratory, where astronauts train for spacewalks in hyper-realistic simulations. But the applications go beyond training. VR can also provide much-needed relaxation and entertainment, offering a mental escape from the confines of a spacecraft or space station. Companies like Oculus and HTC are working with space agencies to develop systems tailored to the unique conditions of space, from microgravity-friendly hardware to content designed to soothe and inspire. The potential impact is profound. By addressing the mental health challenges of space travel, VR could help ensure the success of missions to Mars and beyond. After all, exploring the cosmos isn't just about physical survival, it's about keeping the human spirit strong, even in the most isolated corners of the universe. Our artificial intelligence isn't just changing life on Earth, it's revolutionizing how we explore the cosmos. In the unforgiving environment of space, where every decision carries immense risk and even a slight delay in communication can mean the difference between success and failure, AI is proving to be an indispensable ally. Take NASA Mars rovers, for example. These robotic explorers are equipped with AI that allows them to analyze terrain, avoid obstacles, and even choose their own scientific targets without waiting for instructions from Earth. This autonomy is crucial on a planet where signals can take up to 20 minutes to travel one way. But AI's role goes far beyond rovers. Predictive analytics powered by machine learning are transforming mission planning, helping scientists anticipate potential challenges and optimize resource allocation. Imagine an AI system that can predict equipment failures before they happen, or calculate the most efficient trajectory for a spacecraft through the asteroid belt. These capabilities aren't just about saving time and money. They're about ensuring the safety and success of missions that push the boundaries of human knowledge. Even in space habitats, AI is playing a critical role, managing life support systems, monitoring crew health, and even assisting with scientific experiments. This technology is becoming the backbone of space exploration, enabling us to tackle challenges that were once thought impossible. The more we integrate AI into our missions, the more we're unlocking the potential to explore farther, faster, and more efficiently than ever before. As we look to the stars, it's clear that artificial intelligence isn't just a tool, it's a partner in our quest to understand the cosmos. Imagine materials so small they're measured in billionths of a meter, yet so powerful they could transform how we explore the cosmos. This is the promise of space-based nanotechnology, a field that's redefining the limits of what's possible in space exploration. At its core, nanotechnology involves engineering materials and devices on an atomic or molecular scale, offering incredible strength, flexibility, and functionality. In space, where every gram counts, nano-engineered materials could lead to lighter, stronger spacecraft that consume less fuel and withstand harsh conditions. Think of carbon nanotubes, which are hundreds of times stronger than steel but weigh a fraction as much, making them ideal for constructing habitats on the Moon or Mars. But the applications don't stop there. Nanosensors, tiny yet highly sensitive devices, could monitor everything from radiation levels to air quality in real time, ensuring the safety and efficiency of space missions. Even more futuristic are self-healing materials, embedded with nanoparticles that can automatically repair cracks or damage caused by micrometeoroids or extreme temperatures. Research in this field is already underway, with projects like NAS, a nanotechnology project exploring applications ranging from advanced coatings for spacecraft to nanoscale drug delivery systems for astronaut health. The potential is staggering. Nanotechnology could enable spacecraft that adapt to their environment, habitats that self-sustain, and instruments that outperform anything we've built before. This isn't just about making things smaller. It's about making them smarter, more resilient, and more capable. As we look to the stars, nanotechnology is proving that the smallest innovations can lead to the biggest breakthroughs, paving the way for a future where space exploration is safer, more efficient, and more ambitious than ever. Biotechnology is often associated with breakthroughs in medicine or agriculture here on Earth, but its potential in space is nothing short of revolutionary. Space-based biotechnology takes the principles of genetic engineering and applies them to the unique challenges of life beyond our planet. One of the most exciting applications is the creation of genetically engineered organisms designed to thrive in space environments. Imagine bacteria that can produce oxygen, yeast that generates essential nutrients, or algae that synthesizes fuel, all from the limited resources available in space. These organisms could form the backbone of sustainable ecosystems, supporting long-term missions to Mars or even interstellar travel. On the International Space Station, experiments like the Yeast 2 study have already demonstrated how microbes behave differently in microgravity, offering insights into how we can harness their potential. Beyond food and fuel, biotechnology could revolutionize medicine in space, with genetically engineered bacteria producing antibiotics or even personalized drugs tailored to an astronaut's needs. The possibilities extend to materials as well. Researchers are exploring how microbes can create biodegradable plastics or self-repairing materials that could be used to build habitats. This intersection of biology and space exploration isn't just about survival. It's about creating systems that mimic the resilience and adaptability of life itself. By leveraging the power of biotechnology, we're not just solving challenges, we're reimagining how life can flourish in the cosmos. From producing resources to healing astronauts, this field is proving that the future of space exploration is as much about biology as it is about engineering. Computers have come a long way since the days of room-sized mainframes, but even the most advanced supercomputers struggle with the immense complexity of space exploration. Enter space-based quantum computing, a technology that could redefine how we process information in the cosmos. Unlike traditional computers, which rely on bits that can be either 0 or 1, quantum computers use qubits that can exist in multiple states simultaneously. This allows them to perform calculations at speeds that would take conventional machines centuries to complete. In space, where every second counts, this capability could be a game changer. Quantum computers could simulate the behavior of spacecraft in extreme environments, optimize trajectories for interplanetary travel, or even model the formation of galaxies in unprecedented detail. NASA and Google have already collaborated on projects like the Quantum Artificial Intelligence Lab, exploring how quantum computing can solve problems that are currently beyond our reach. But the applications don't stop at simulations. Quantum systems could also revolutionize communication, encryption, and data analysis, ensuring that missions operate seamlessly even millions of miles from Earth. The challenge lies in making these systems reliable and compact enough for space, where resources are limited and conditions are harsh. Research is underway to develop quantum processors that can withstand radiation and operate in microgravity, paving the way for their integration into future missions. This isn't just about faster calculations, it's about unlocking solutions to challenges we haven't even imagined yet. As we push the boundaries of exploration, quantum computing could be the key to unlocking the secrets of the universe and ensuring humanity's success in the stars. Navigating the complexities of space isn't just about physical endurance, it's about processing vast amounts of information in real time, often under immense pressure. This is where space-based augmented reality, or AR, steps in, offering a powerful tool to enhance how astronauts see, interact with, and understand their environment. Imagine a visor that overlays critical data directly onto an astronaut's field of view, highlighting the safest path across a rocky Martian surface, identifying tools for a repair task, or even displaying vital signs in the corner of their vision. This isn't science fiction, it's the future of space exploration, and it's already being tested. NASA Project Sidekick, for instance, uses Microsoft's HoloLens to assist astronauts on the International Space Station, providing step-by-step guidance for complex procedures and reducing the risk of errors. But AR's potential goes beyond real-time assistance. During training, it can create immersive simulations that prepare crews for the unpredictable challenges of space, from zero-gravity repairs to emergency scenarios. Companies like Magic Leap are also exploring how AR can improve mission control, allowing teams on Earth to visually collaborate with astronauts in real time. The implications are profound. Augmented reality bridges the gap between human intuition and machine precision, creating a seamless partnership that enhances efficiency and safety. This technology isn't just about making tasks easier, it's about empowering astronauts to perform at their best, even in the most demanding environments. As we push further into the cosmos, AR is proving that the key to success lies not just in advanced hardware, but in enhancing how humans and machines work together. While solar panels have become a staple of space exploration, what if we could tap into even more abundant sources of energy floating in the cosmos? Space-based energy harvesting is an emerging field that seeks to capture and utilize energy from the very fabric of space itself. Solar winds, for instance, are streams of charged particles ejected from the sun, carrying immense energy potential. By deploying specialized collectors, we could harness this energy to fuel spacecraft or even entire colonies. Another promising source lies in planetary magnetic fields, which generate electrical currents that can be captured using innovative technologies. Think of it as drawing power from the invisible forces that shape our solar system. Researchers are already exploring prototypes such as magnetic sails, which use the interaction between solar winds and onboard magnetic fields to propel spacecraft without traditional fuel. Similarly, projects like the Heliopause Electrostatic Rapid Transit System, or HERTS, aim to ride solar winds for faster travel to the outer planets. The implications are staggering. Space-based energy harvesting could eliminate the need to carry heavy fuel reserves, making missions lighter, cheaper, and more sustainable. This isn't just about powering spacecraft, it's about unlocking new possibilities for exploration, enabling us to venture farther and stay longer in the cosmos. As we continue to push the boundaries of energy innovation, these technologies are proving that the universe itself could be the ultimate power source, offering a renewable and limitless supply of energy for humanity's journey among the stars. Gravity may be essential to life on Earth, but when it comes to creating groundbreaking materials, sometimes its absence is the key to innovation. Space-based materials science is unlocking a treasure trove of possibilities, leveraging the microgravity environment to produce substances with properties that are simply unattainable on our planet. In the weightless conditions of orbit, materials behave differently. Liquids don't settle, gases don't rise, and particles don't clump together in the same way. This opens the door to synthesizing ultra-strong alloys, lightweight composites, and even flawless crystals that could revolutionize industries from aerospace to medicine. On the International Space Station, experiments like the Materials Science Lab are already yielding remarkable results, creating metals with unprecedented strength-to-weight ratios and semiconductors with perfect atomic structures. Take ZBLAN, a type of glass fiber that's far more transparent than anything made on Earth, with the potential to improve global internet speeds dramatically. These space-synthesized materials aren't just scientific curiosities, they're practical solutions to real-world challenges. For example, stronger alloys could lead to more durable spacecraft, while lightweight composites might make sustainable aviation a reality. The implications for Earth-based industries are staggering, from faster electronics to more efficient energy systems. This isn't just about advancing science, it's about transforming how we build, create, and innovate across the globe. By harnessing the unique conditions of space, materials science is proving that the next industrial revolution might just start in orbit. As we look outward to the stars, it's easy to forget that some of the most critical innovations in space technology are focused on protecting the planet we call home. Space-based environmental monitoring is a prime example, using satellites to track changes on Earth with unprecedented precision. These orbiting observers are like global watchdogs, capturing data on everything from deforestation and melting ice caps to air pollution and ocean health. Satellites like the European Space Agency's Sentinel series and NASA's Landsat program have become indispensable tools for scientists, providing real-time insights into the health of our planet. For instance, satellite imagery has revealed the alarming rate of deforestation in the Amazon, while sensors monitor carbon dioxide levels in the atmosphere, helping us understand the drivers of climate change. The impact of this technology goes beyond data collection. It's about empowering decision-makers with the information they need to take action. Governments and organizations use this data to enforce environmental regulations, plan conservation efforts, and even predict natural disasters before they strike. Projects like the Global Forest Watch, which uses satellite data to combat illegal logging, highlight the tangible benefits of this approach. By offering a bird's-eye view of Earth systems, space-based monitoring is proving to be a critical ally in the fight against environmental degradation. This isn't just about observing our planet, it's about preserving it for future generations. As we continue to face global challenges, from climate change to biodiversity loss, these satellites remind us that the solutions to Earth's problems might just lie in the stars above. Natural disasters like earthquakes, hurricanes, and tsunamis have long been a devastating force on Earth. But what if we could predict them with pinpoint accuracy before they strike? Space-based disaster prediction is transforming how we understand and respond to these events, using satellites and artificial intelligence to monitor our planet in ways never before possible. Satellites equipped with advanced sensors can detect subtle changes in Earth's surface, atmosphere, and oceans, providing early warnings for disasters that might otherwise catch us off guard. For example, Japan's ALOS 2 satellite uses radar to measure ground deformation, offering clues that could help predict earthquakes. Similarly, NASA's satellites track hurricanes in real time, monitoring wind speeds, storm paths, and intensity changes to give communities crucial time to prepare. But the real game changer is the integration of AI, which can analyze massive amounts of data from these satellites to identify patterns and predict disasters with unprecedented precision. Projects like the European Space Agency's Crystal mission are pushing boundaries, using radar altimeters to monitor rising sea levels and predict coastal flooding. The potential to save lives and reduce economic damage is enormous. Imagine evacuating areas hours before a tsunami hits or fortifying infrastructure days before an earthquake strikes. This isn't just about technology, it's about creating a future where natural disasters no longer catch us by surprise. By leveraging the power of space and AI, we're turning the tide on humanity's battle with nature, ensuring we're not just reactive but truly prepared for the challenges ahead. As the impacts of climate change become increasingly severe, scientists are looking beyond Earth for solutions literally. Space-based climate control is an ambitious concept that aims to use advanced technologies to stabilize our planet's environment, offering a lifeline in the fight against global warming. One of the most discussed ideas involves deploying massive solar reflectors or shields in space to reduce the amount of sunlight reaching Earth, effectively cooling the planet. These reflectors could be positioned at strategic points, such as the Lagrange 1 point, where the gravitational forces of the Earth and Sun balance, allowing them to remain stationary. Another approach focuses on carbon capture, using satellites equipped with specialized systems to remove greenhouse gases from the atmosphere, storing or repurposing them in ways that benefit the planet. Projects like the University of Cambridge's Strato Shield and the European Space Agency's Scarab study are already exploring these possibilities, testing prototypes and refining the science behind them. The potential benefits are immense. By mitigating the effects of climate change, we could protect vulnerable ecosystems, reduce extreme weather events, and secure a more stable future for generations to come. However, these technologies also raise significant ethical questions. Who decides how much sunlight to block or where to deploy these systems? What unintended consequences could arise from altering Earth's delicate balance? These are complex issues that require careful consideration and international collaboration. Despite the challenges, space-based climate control represents a bold step forward in our efforts to address environmental crises. It's a reminder that sometimes the most innovative solutions require thinking outside the planet literally. As we continue to explore these ideas, one thing is clear: the fight against climate change demands creativity, courage, and a willingness to push the boundaries of what's possible. For centuries, humanity has looked to the stars with wonder, curiosity, and a desire to learn. Now, space-based education programs are bringing that sense of awe directly into classrooms, inspiring the next generation of explorers, scientists, and dreamers. Imagine students logging into a virtual classroom hosted aboard the International Space Station, where astronauts share real-time lessons on everything from physics to biology, all while floating in microgravity. Programs like NASA's STEM on Station are already making this a reality, offering live video chats, hands-on experiments, and educational resources that bring the wonders of space into schools around the world. These initiatives aren't just about teaching facts, they're about sparking curiosity and showing young minds that the sky is not the limit, it's just the beginning. Beyond virtual classrooms, space-themed curricula are also gaining traction, integrating space exploration into subjects like math, history, and art. For example, the European Space Agency's Teach with Space program provides teachers with tools to create engaging lessons that connect students to the cosmos. The impact is profound. Studies show that exposure to space-related education increases interest in STEM fields, particularly among underrepresented groups. This isn't just about creating future astronauts. It's about equipping students with the skills and passion to tackle the challenges of tomorrow, whether in space or here on Earth. By making space education accessible and exciting, we're planting the seeds for a future where exploration and innovation thrive. The journey to the stars starts in the classroom, and today's students are the pioneers who will take us there. Life in space isn't just about survival, it's also about finding ways to thrive, and that's where space-based entertainment comes into play. Imagine a game of zero-gravity soccer where players soar through the air, or a zero-G dance performance that turns the entire spacecraft into a stage. These aren't just flights of fancy, they're real possibilities being explored by companies and space agencies alike. SpaceX and Virgin Galactic are already envisioning how space tourism could offer once-in-a-lifetime experiences, from floating concerts to movie nights under the stars. But entertainment in space goes beyond just fun. It plays a crucial role in mental health and well-being. Long-term missions can be isolating and stressful, and leisure activities help astronauts recharge and stay focused. On the International Space Station, astronauts have enjoyed everything from watching Earth sunrises to playing musical instruments, proving that even in space, there's room for joy and creativity. Projects like the Space Entertainment Enterprise are taking this a step further, developing space-themed films and experiences designed specifically for zero-gravity environments. The idea is to make space travel not just bearable but truly enriching, blending adventure with relaxation. This focus on entertainment isn't just a luxury, it's a necessity for ensuring that space travelers remain mentally and emotionally resilient. By creating opportunities for play and relaxation, we're making space a place where humanity can flourish, not just endure. After all, exploration isn't just about reaching new frontiers. It's about bringing the best of who we are along for the journey. Our art has always been a reflection of human imagination and experience, and as we venture into space, it's only natural that creativity follows. Space-based art is emerging as a powerful way to capture the wonder and mystery of the cosmos, blending science and imagination in ways that inspire and connect us all. Artists around the world are drawing inspiration from space, whether it's through paintings, sculptures, or even performances that take place in zero gravity. One groundbreaking example is the first art installation in space, the Orbital Reflector, a reflective satellite designed to be visible from Earth as a shimmering point of light. Created by artist Trevor Paglen, this project isn't just about aesthetics, it's about redefining how we see and interact with the universe. But space-based art isn't limited to installations. It also includes the work of astronauts themselves, who often document their experiences through photography, painting, and even music. These creations offer a deeply personal perspective on space, reminding us that exploration isn't just a scientific endeavor, it's a profoundly human one. Beyond its beauty, space-based art has the power to unite people across cultures and generations, sparking conversations about our place in the cosmos and the future we're building together. By integrating art into space exploration, we're not just expanding our horizons, we're enriching our understanding of what it means to be explorers and dreamers. This fusion of creativity and science reminds us that the journey to the stars is as much about storytelling as it is about discovery, shaping how we see ourselves and our universe. While archaeology has always been about digging into the past, what if the key to unlocking ancient mysteries lies not beneath our feet but high above our heads? Space-based archaeology is revolutionizing the way we study human history. using satellites and advanced imaging technology to uncover hidden structures and artifacts that have remained invisible for centuries. These orbiting observatories, equipped with tools like LiDAR and high-resolution cameras, can penetrate dense forests, arid deserts, and even urban landscapes to reveal the outlines of lost cities, ancient roads, and forgotten monuments. One of the most remarkable examples is the discovery of thousands of previously unknown Mayan structures in the dense jungles of Central America, thanks to satellite imagery. Projects like UNESCO Space for Heritage Initiative are using these technologies to map and protect cultural sites around the world, from the pyramids of Egypt to the ancient ruins of Mesopotamia. But it's not just about finding what's been lost. Space-based archaeology offers new ways to understand how ancient civilizations lived, traded, and interacted with their environments. For instance, satellite data has revealed intricate irrigation systems that sustained the Indus Valley civilization and massive road networks that connected the Roman Empire. Beyond the thrill of discovery, this field plays a crucial role in preserving our global heritage, especially as natural disasters, urban development, and climate change threaten these irreplaceable sites. By combining the power of space technology with the curiosity of archaeology, we're not just uncovering the past, we're ensuring it has a future. As we continue to explore the cosmos, these tools remind us that sometimes the best way to move forward is by looking back from a whole new perspective. Imagine a crew of astronauts from different corners of the globe working together on a mission to Mars. While their expertise might complement each other perfectly, what happens when language becomes a barrier? Space-based language translation is stepping in to solve this challenge, using AI-powered systems to ensure seamless communication among international crews. These advanced tools go beyond traditional translation software, offering real-time interpretation with remarkable accuracy, even in the high-pressure environment of space. Think of it as a multilingual assistant that not only translates words but also understands context, tone, and intent, making conversations flow as naturally as if everyone spoke the same language. Projects like NAS, a universal translator, are already testing these systems aboard the International Space Station, where astronauts from diverse backgrounds work side by side. The implications are profound. By breaking down language barriers, these technologies foster collaboration, reduce misunderstandings, and enhance mission safety. But the potential doesn't stop there. As humanity sets its sights on international missions to the Moon, Mars, and beyond, translation tools could play a pivotal role in uniting people from different cultures and nations under a shared goal of exploration. This isn't just about convenience, it's about creating a future where language is no longer a barrier to teamwork or discovery. By enabling clear and effective communication, space-based translation systems are proving that the key to exploring the cosmos lies not just in advanced technology, but in our ability to work together as one global team. Navigating the cosmos isn't just about knowing where you are, it's about knowing when you are. In space, where traditional clocks can be thrown off by the extreme conditions and the effects of relativity, timekeeping becomes a critical challenge. Enter space-based atomic clocks, a revolutionary invention designed to keep time with unparalleled precision, even in the vacuum of space. These devices rely on the natural vibrations of atoms, such as cesium or rubidium, which remain incredibly stable regardless of external conditions. This stability is essential for missions that demand split-second accuracy, from coordinating spacecraft maneuvers to ensuring seamless communication across vast distances. Projects like NAS, a deep space atomic clock, have already demonstrated their potential, showing how these clocks can maintain accuracy to within a billionth of a second over decades. The implications are profound. Precise timekeeping is the backbone of GPS-like systems that could guide future missions to Mars and beyond, ensuring astronauts and rovers can navigate with confidence. But it's not just about space travel. These clocks also play a crucial role in synchronizing satellite networks, enabling everything from global internet access to disaster response systems. Research in this field continues to push boundaries, with prototypes like the European Space Agency's ACES mission aiming to test atomic clocks on the International Space Station. This isn't just about measuring time, it's about creating a framework that underpins the safety and success of every mission. As we venture deeper into the cosmos, the ability to keep time with absolute precision is proving to be one of the most essential tools in humanity's exploration toolkit, a silent but indispensable companion in our journey among the stars. Imagine having a highly intelligent assistant by your side, ready to help with everything from scheduling your day to solving complex technical problems. Now picture that assistant floating in zero gravity, right there with you in space. Space-based virtual assistants are becoming a reality, powered by artificial intelligence to support astronauts in their daily tasks and mission-critical operations. These aren't just glorified calendars, they're sophisticated systems capable of analyzing data, troubleshooting issues, and even offering mental health support during long, isolating missions. Think of them as a blend of a personal assistant, a technical expert, and a confidant, all rolled into one. Projects like NASA's Crew Interactive Mobile Companion, or SIMON, have already tested these concepts aboard the International Space Station. SIMON, a spherical AI assistant, demonstrated its ability to guide astronauts through complex procedures and provide real-time problem-solving support. The potential benefits are immense. By handling routine tasks and offering expert advice, virtual assistants free up astronauts to focus on the more creative and challenging aspects of their missions. But the innovation doesn't stop there. These systems are also being designed to adapt to individual crew members, learning their preferences and needs to provide personalized support. As missions grow longer and more complex, virtual assistants could become indispensable partners, ensuring that astronauts remain productive, efficient, and mentally resilient. This integration of AI into space exploration isn't just about making life easier. It's about amplifying human potential, allowing us to achieve more than we ever thought possible. By working hand in hand with these intelligent systems, astronauts are paving the way for a future where technology and humanity work seamlessly together to unlock the mysteries of the cosmos. As humanity's reliance on space technology grows, so does the need to protect it from cyber threats. Space-based cybersecurity is emerging as a critical field, dedicated to safeguarding satellites, spacecraft, and the networks that connect them from hacking, data breaches, and other malicious attacks. Imagine the chaos if a hacker were to disrupt GPS navigation systems, interfere with climate monitoring satellites, or even take control of a spacecraft. These aren't hypothetical scenarios but real risks that demand urgent attention. The challenges are immense. Space systems are inherently vulnerable due to their remote locations, limited processing power, and reliance on long-distance communication. Add to that the complexity of coordinating defenses across international borders, and the task becomes even more daunting. Despite these hurdles, researchers and engineers are developing innovative solutions to fortify space infrastructure. One approach involves advanced encryption techniques that secure data transmissions between Earth and orbit, ensuring that only authorized users can access critical information. Another strategy focuses on building redundancy into systems, so even if one component is compromised, others can take over seamlessly. Projects like the U.S. Space Force's Cyber Command and the European Space Agency's Secure SATCOM initiative are leading the charge, testing prototypes and refining protocols to stay ahead of cyber threats. But this isn't just about technology. It's about creating a culture of vigilance and collaboration among space agencies, private companies, and governments. By prioritizing cybersecurity, we're not just protecting satellites and spacecraft, we're ensuring the safety and reliability of the technologies that shape our daily lives on Earth and beyond. In an era where space is becoming the next frontier for exploration and innovation, safeguarding these systems is essential to our shared future among the stars. As humanity reaches further into space, it's not just technology we'll need to carry with us, it's the rule of law. Space-based legal frameworks are becoming an essential component of our cosmic ambitions, ensuring that exploration and resource use are governed by clear, fair, and universally accepted rules. Think about it: who owns the moon? Who has the rights to mine an asteroid? These aren't just philosophical questions, they're practical dilemmas that demand immediate answers. The challenge lies in creating laws that are both comprehensive and adaptable, capable of addressing everything from property rights to environmental preservation in an environment completely unlike Earth. Current agreements like the Outer Space Treaty of 1967 laid the groundwork, but they were designed for a time when space exploration was in its infancy. Today, with private companies and multiple nations vying for a piece of the cosmos, the need for updated frameworks is more urgent than ever. Initiatives like the Hague International Space Resources Governance Working Group are making strides, developing guidelines for sustainable resource use beyond Earth. The goal is to prevent conflicts and ensure that space remains a shared frontier, not a battleground. This isn't just about avoiding disputes, it's about fostering collaboration and innovation. By establishing clear legal boundaries, we can create an environment where exploration thrives, resources are used responsibly, and new opportunities are accessible to all. Governance in space may not sound as exciting as rockets or Mars colonies, but it's the foundation that will make all of it possible. Without it, the cosmos risks becoming a lawless frontier, something that no one can afford. By addressing these challenges head-on, we're not just preparing for the future, we're shaping it to be fair, just, and infinitely more promising. As humanity ventures further into the cosmos, we're not just grappling with technological challenges, we're also confronting profound ethical questions. Space-based ethics is a growing field that examines the moral implications of our journey beyond Earth, from how we interact with extraterrestrial environments to the rights and responsibilities of future space colonists. One of the most pressing concerns is the potential impact of human activity on other planets or moons. For instance, if we discover microbial life on Mars, how do we ensure our exploration doesn't harm or erase it? The concept of planetary protection is already guiding missions, with guidelines to prevent contamination of other worlds. But as we move toward colonization, these questions become even more complex. Who owns the resources we extract from asteroids or lunar soil? Should space settlements operate under Earth's laws, or will they need entirely new legal and ethical frameworks tailored to their unique environments? These debates are already taking shape, with organizations like the Committee on Space Research, or COSPAR, working to establish international standards. Meanwhile, discussions about the rights of space colonists, from freedom of movement to access to resources, are gaining traction, especially as private companies like SpaceX and Blue Origin push the boundaries of commercial space travel. At the heart of these conversations is a simple but powerful idea: exploration should be responsible. This means balancing our ambitions with a commitment to preserving the integrity of the cosmos and ensuring fairness for those who follow. After all, space isn't just a frontier to conquer, it's a shared heritage that belongs to all of humanity. By addressing these ethical challenges head-on, we're not just preparing for the future, we're shaping it to be just, sustainable, and respectful of the incredible environments we're privileged to explore. Space has always been a canvas for human imagination, but it's also a mirror reflecting profound questions about who we are and our place in the universe. Space-based philosophy is an emerging field that uses the challenges and wonders of exploration to explore timeless questions about life, existence, and meaning. For centuries, philosophers have pondered the nature of reality, the origins of life, and humanity's role in the cosmos. And now, space exploration is providing new ways to approach these mysteries. Take the famous overview effect, the profound shift in perspective astronauts experience when they see Earth from space. This phenomenon isn't just awe-inspiring. It sparks deep reflections on interconnectedness, fragility, and the responsibility we share for our planet. Space also challenges us to rethink our assumptions about life itself. If we discover extraterrestrial life, how would that reshape our understanding of biology, ethics, and even religion? These questions aren't just theoretical, they're already shaping discussions in academia, science, and culture. Organizations like the Arch Mission Foundation are even sending philosophical texts and cultural archives into space, ensuring that humanity's intellectual legacy survives beyond our planet. But space-based philosophy isn't just about big questions, it's about practical insights too. For instance, the ethics of colonizing other worlds forces us to confront issues like fairness, sustainability, and the rights of future generations. This dialogue is more than academic, it's a crucial part of ensuring that space exploration benefits all of humanity, not just a select few. By blending science with philosophy, we're not just exploring the cosmos, we're deepening our understanding of ourselves. It's a reminder that every mission, every discovery is part of a larger journey, one that invites us to think bigger, dream bolder, and connect more deeply with the universe and one another. Throughout history, humanity has looked to the skies not just for answers about the universe, but for meaning in our own existence. Space-based religion is an evolving field that examines how faith and spirituality intersect with our journey beyond Earth. For many, the cosmos has long been a source of wonder and reverence, inspiring stories, rituals, and beliefs across cultures and religions. From the ancient Greeks who saw the stars as gods, to indigenous traditions that link celestial events to creation myths, the heavens have always been deeply intertwined with the human spirit. As we venture into space, these connections are taking on new dimensions. Some faiths, like Christianity and Islam, incorporate space exploration into their narratives, viewing it as an extension of humanity's divine purpose. Others, like Buddhism and Hinduism, see parallels between the vastness of the cosmos and spiritual concepts of infinity and interconnectedness. But space isn't just a backdrop for existing beliefs, it's also a catalyst for new ones. The overview effect, the profound sense of awe and unity experienced by astronauts when viewing Earth from space, has inspired discussions about spirituality beyond traditional frameworks. Some even speculate that discovering extraterrestrial life could spark entirely new religious movements, reshaping our understanding of creation and existence. These conversations aren't just theoretical, they're already influencing space policy and ethics. Organizations like the Vatican Observatory are actively engaging in dialogue about the moral and spiritual implications of exploration. At its core, space-based religion reminds us that the journey to the stars isn't just about science and technology, it's about the human spirit's quest for meaning. By embracing diverse perspectives, we're not just exploring the cosmos, we're enriching our shared understanding of what it means to be human in a vast and mysterious universe. Exploring the stars isn't just a scientific endeavor, it's also a powerful tool for bringing nations together. Space-based diplomacy is reshaping how countries interact, using shared missions and projects to build bridges and foster cooperation. At a time when geopolitical tensions can dominate headlines, space offers a unique opportunity to shift the focus toward collaboration rather than conflict. Initiatives like the International Space Station, where nations as diverse as the United States, Russia, Japan, and European countries work side by side, demonstrate the potential of space to unite humanity around a common goal. These partnerships aren't just about sharing resources or expertise. They're about building trust and understanding between cultures. Even during periods of strained Earth-based relations, space has often remained a neutral ground where collaboration continues, proving that the challenges of exploration are best tackled together. Programs like the Artemis Accords, which aim to establish a framework for peaceful and sustainable lunar exploration, are further examples of how space diplomacy can pave the way for a more cooperative future. The impact goes beyond just missions. It's about creating a mindset where nations see space as a shared frontier, not a battleground. This approach doesn't just benefit space exploration, it sets a precedent for solving global challenges here on Earth, from climate change to resource scarcity. As we look to the stars, it's clear that the journey isn't just about reaching new destinations. It's about uniting humanity to achieve what no single nation could accomplish alone. Space-based diplomacy reminds us that the greatest discoveries often come when we work together, turning the cosmos into a symbol of hope and shared purpose for all. Space isn't just the final frontier, it's also the next frontier for economic innovation. From asteroid mining to space tourism, the economic potential of space exploration is vast, offering opportunities that could reshape industries here on Earth and beyond. Take asteroid mining, for example. These rocky remnants of the solar system's formation are packed with valuable resources like platinum, rare earth metals, and even water, which can be converted into fuel. The financial implications are staggering. A single asteroid could contain trillions of dollars worth of materials, potentially revolutionizing industries from electronics to renewable energy. Space tourism is another booming sector, with companies like SpaceX and Blue Origin offering civilians the chance to experience the wonder of zero gravity. This isn't just about luxury, it's about opening up space to a broader audience, democratizing access and inspiring a new generation of explorers. But building a sustainable space economy isn't without its challenges. High costs, regulatory hurdles, and the harsh realities of space environments all pose significant obstacles. Solutions are already in the works, from reusable rockets that slash launch expenses to international agreements that ensure fair and ethical resource use. Projects like Luxembourg's Space Resources Initiative and NASA's Artemis Accords are paving the way for a new era of space commerce. The goal isn't just profit, it's creating a framework that supports long-term exploration and benefits humanity as a whole. As we look to the stars, it's clear that economic viability is essential for turning ambitious dreams into reality. Without a sustainable economic model, our cosmic ambitions risk being grounded before they can truly take flight. The innovations driving space exploration today could soon become the engine of a thriving interstellar economy, ensuring that the stars are within reach for generations to come. As we push forward into the cosmos, it's easy to focus on the future, but what about the past? Space-based history is an emerging field dedicated to documenting and preserving the incredible journey of human space exploration, ensuring that the achievements, challenges, and lessons learned aren't lost to time. Think of it as a cosmic archive, capturing everything from the first satellites launched into orbit to the monumental moments of lunar landings and Mars rovers. This isn't just about nostalgia, it's about creating a tangible record for future generations to learn from and build upon. Projects like the Arch Mission Foundation are already taking steps in this direction, sending libraries of human knowledge, from Wikipedia to cultural artifacts into space, etched into durable materials designed to last for millennia. Meanwhile, initiatives like the International Space Station's historical records ensure that every experiment, every mission, and every discovery is meticulously logged and preserved. But the concept goes beyond just archives. It includes the idea of space-based museums where future explorers can visit historic landing sites, spacecraft, and even personal artifacts left behind by astronauts. Imagine standing on the Moon and seeing the Apollo 11 landing site, not just as a relic but as a living monument to human ingenuity. These efforts aren't just about safeguarding history, they're about inspiring future generations to dream bigger and reach further. By documenting our journey into space, we're not just preserving the past, we're laying the groundwork for a future where exploration continues to thrive. It's a reminder that every giant leap we take builds on the steps of those who came before, ensuring that their legacy lights the way for the explorers of tomorrow. Space-based future visions aren't just about what we're building, they're about what we're becoming. As we push the boundaries of space exploration, we're not just colonizing planets or searching for extraterrestrial life, we're redefining humanity's place in the cosmos. Picture a future where thriving cities on Mars are connected to Earth by regular space travel, where lunar outposts serve as hubs for scientific discovery, and where the search for life beyond our planet yields groundbreaking answers to one of our oldest questions: are we alone? These aren't just lofty dreams, they're possibilities being actively pursued by scientists, engineers, and visionaries around the world. But the impact of these endeavors goes far beyond space itself. The technologies developed for exploration, from sustainable habitats to advanced propulsion systems, have the potential to transform life on Earth, addressing challenges like resource scarcity, climate change, and energy efficiency. Discussions about the ethics of colonizing other worlds, the equitable distribution of space resources, and the implications of extraterrestrial contact are also shaping how we approach these ventures. Organizations like the United Nations Office for Outer Space Affairs are working to ensure that space exploration benefits all of humanity, not just a select few. What ties these ideas together is a shared belief in the power of imagination. Dreaming big isn't just a luxury, it's a necessity. Every invention, every mission, and every discovery is a step toward a future where the stars are no longer out of reach but part of our everyday reality. By embracing these visions, we're not just exploring space, we're shaping the future of humanity itself, one bold idea at a time. And there you have it, 50 groundbreaking inventions that could redefine how we live, work, and explore beyond Earth. From self-sustaining habitats and artificial gravity systems to asteroid mining and quantum communication, these innovations represent the pinnacle of human ingenuity and ambition. Each invention tackles a unique challenge, whether it's protecting astronauts from cosmic radiation, recycling every drop of water, or creating sustainable energy sources far from our planet. But what ties them all together is a shared vision of a future where humanity not only survives in space but thrives. These technologies aren't just about overcoming physical barriers. They're about fostering collaboration, sustainability, and a deep respect for the cosmos we're privileged to explore. They remind us that the journey to the stars is not just a scientific endeavor but a collective one, uniting nations, industries, and individuals around a common goal to push the boundaries of what's possible. As you reflect on these inventions, imagine a world where lunar colonies are as common as skyscrapers, where interstellar travel is as routine as a flight across the globe, and where the mysteries of the universe are within our reach. Which of these inventions excites you the most? Let us know in the comments below. We'd love to hear your thoughts. If you're as inspired by these possibilities as we are, don't forget to hit that subscribe button and join us as we continue to explore the cutting edge of futuristic technology. Together, let's dream bigger, reach further, and shape a future where the stars are just the beginning. Thank you for watching, and we'll see you in the next video.